Okay, this is a displacement function, and we want to show that the object is initially at the origin, which means that when time is 0, we want this displacement to be 0. So we can now work through this out by saying, okay, what will happen at t is equal to 0? So we'll just substitute. And this will be minus ln1, which is 0. So in this case, our object is initially at the origin. If it was on the left-hand side, displacement would be negative. If it was on the right-hand side, its displacement would be positive. Now we need to find the velocity function. From the displacement function, we can find the velocity function, and that will be just 1 minus 2 over 2t plus 1. And this object is moving at centimeters per second. We know that the velocity function, if it is greater than 0, then the object is moving to the right. And we also know that if the velocity function is less than 0, then the object is moving to the left. So what we need to do is find out at what time is it actually moving to the right or to the left, or if it is actually moving to the right or left. We can only do this by making this equal to 0. So if I make that equal to 0, I will be able to find the sign diagram. So I make that 2 over 2t plus 1. I don't want to separate the 1 and the negative 2t by putting the 1 onto the other side or that to the other side. What I'm going to do is put them under the same common denominator. So this means that I will have to multiply the 1 by 2t plus 1 over 2t plus 1, and then if I have that under 2t plus 1, that's all under the same common denominator, so I can now say that it's 2, which is 2t minus 1 over 2t plus 1. Now remember, that's going to equal to 0. So what exactly happens if that is equal to 0? Well, that means that my numerator must be equal to 0. So I'm going to... So at time equals a half, we can say that the object changes its velocity. Simply saying, it means it changes its direction. To decide at what time interval is the object moving to the right or to the left, we need to do a sign diagram. The sign diagram starts with time is equal to 0. And we know that it changes direction at time is equal to a half. So now decide which is negative and which is positive. If I choose, for instance, TB0 for this section here, and I insert it into the velocity function, either up here or even up in here, 0, that becomes 0. The minus 1 over plus 1 is a negative number. In that case, our sign will show me a negative sign. If I now happen to choose maybe a value of 1 and put 1 in here, that would be 2, take away 1 is 1, and 2 plus 1 is 3. That'll give me a positive number, so I can quite confidently say that this is going to be a positive sign over here. And so what this means is that on this side here, the object is moving to the left, and on that side of the time, after time is a half, it'll be moving to the right. So we can write that the object is moving to the right when t is greater than, and the object is moving to the left when t is greater or equal to 0 and less than a half. It can't be less than and equal because it can't be moving left and right at a half at time equals. It's one or the other. To show the object's acceleration, we need to differentiate the velocity. So if velocity is this, then I will want to change this to help me better understand it. It'll be 1 minus 2, and I will write this in the exponent. So 1 to the minus 1. It'll be easier to do the differentiation. So therefore, the acceleration will be, using the chain rule, 4 over 2t plus 1 all squared centimeter per centimeter. To find out whether the acceleration is positive or negative, we will need to draw the sign diagram for this. And the sign diagram will start with time is equal to 0. And because the t is in the denominator over here, is this function will always be positive. Okay, so to find out the distance that the object traveled in the first 2 seconds is a little bit more complicated because we know that it started at the origin. So if I draw a position diagram, this time it's position, and I can mark my origin somewhere along here, that this is my origin. We know that that object went left for half a second and then changed direction. So it was going left. Now, how far did it get to when it started going left? And then it changed its course to go right again. So I want to know how far did it go left? Well, I'll need to look up my displacement and say for half a second, what happened after half a second with my displacement? I need to remind myself what that displacement function looked at, and I'll write it just down here. Okay, now I can use that to put my values in for t, and that's minus ln, and work it out. Now this is a difficult concept for me to think about. Half minus ln 2, what does it really mean? It's approximately minus 0.19 centimeters, which means that this length here is not minus 0.19 centimeters, but 0.19 centimeters, because this is minus 0.19. Okay. What I'm trying to say is that the distance is not the same as the displacement. The distance is 0.19 centimeters to the left, which means that we should say that the distance is minus a half minus ln2, which is equal to minus a half plus ln2. That is the distance. Okay, bear with me. We're told that at half a second, he changes direction and then moves to the right. So now I want to ask you another question. I want to say, how far did he move to the right in the first 2 seconds? And please remember that this displacement function will tell me how far he is displaced to the right, not the distance that he moved to the right, but how far is he at 2 seconds. So the displacement, if I insert the value for 2, the answer will be 2 minus ln 5 centimeter. Again, what is 2 minus ln 5 centimeters? All right, it's approximately 0.39 centimeters to the right. Okay, let's go back to my diagram over here. That means that it probably ends up somewhere around here, 0.39. So we can extend our line. He ends up being here. Now, that 0.39 is this length up here, whereas the 0.19 is this length up over here. So what we really want, if we want to find the distance, the length is going to be, okay, I'll put this length plus that length, okay? So, which will look a little bit like this. So we've got minus a half plus ln2 plus minus a half plus ln2 plus 2 minus ln 5. All right, so we can now add that minus a half plus 2 is just 1. And then we have ln2 plus ln2 minus ln 5. If you go to our log rules, you'll discover that, for instance, ln m plus ln p really is ln m times p. Okay, and ln m, take away ln p is equal to ln m divided over p. Yeah, so we can write that this is equal to 1 plus ln 2 times 2 divided by 5, okay, which is equal to 1 plus ln 4 divided by 5.